In this video, what I'm going to show you is how to draw a hexagonal prism, how to cut the prism and show the cut on the different views in orthographic projection, and then develop the true shape of the cut surface. So I started off by moving down 220 millimeters from the top of the sheet, and in 150 millimeters from the left hand side to this point here of the plan. Now each side on the hexagon is going to be 30 millimeters. So I drew in this line here 30 millimeters as part of the plan, and I've drawn down a 60-degree angle and a 60-degree angle, and I've used a compass to strike off 30 millimeters and 30 millimeters. Okay, I then bring the 2 points down vertically, and then I strike again off the 30 millimeters and 30 millimeters. Okay, so that will give me the outline of the hexagon on plan, which I'm going to just finish drawing in. So again, just to check that, so 1, 2, 3, all points correlating, 1, 2, and then 3. So a perfect hexagon drawn in there, and I'm going to now proceed to draw it in using ink. So what we have now is the hexagon on plan. So what I'm going to do now is I'm going to bring those points from plan up onto an elevation. So I'm going to space the elevation, the XY line of the elevation, the ground line of the elevation, 20 millimeters above the plan. And I'm going to draw my XY line, the ground line of the elevation. I'm now going to proceed to bring up all of the points from the plan to form the elevation. Now the height of the elevation, the height of the hexagonal prism is 90 millimeters. Measure up 90, and I proceed to draw the top of the prism. Now I have the elevation drawn in now, and I'm going to ink it in. So the top of the elevation, bottom of the elevation, and the vertical lines of the elevation. So now we have the elevation and the plan of the hexagonal prism. Now what I'm going to proceed to do is to draw in the end views. So the end view on the right hand side will be looking in from the left. The end view on the left hand side will be looking in from the right. So I do that by simply drawing my points up at 45 degrees from the plan. Wrong point, that point there. Then extend those points up vertically for the side views. And I bring my height across from the elevation. Now, I'm going to proceed to draw in the construction lines in red. Okay, so now I'm going to draw in the two end views. And now the vertical lines. So now what we have is the elevation the plan, the end view, looking in from the left hand side, and the end view looking in from the right hand side. Okay, so what we do next is insert a cut. So the cut that I'm going to insert will be at 45 degrees. And I'm going to move up 30 millimeters from on the left hand side, move up 30 millimeters, and the cut will be at 45 degrees. So that's indicating the cut now. Now, how does that cut impose itself on the other views? So first of all, with regards to the plan, it does not affect the plan because both points of the cut, the left hand side point and the top point, right, both of those points are on the sides. Okay, it does not cut through the top. So because they both cut these 2 points of the cut the sides, you have a full hexagon in the as a cut on plan. So it doesn't impose any other line on the plan because the 2 points, extreme points of the cut, go through the sides. However, it does affect the end views. So the points in the end view, if I bring the points across on the end view. So again, I'll just simply use a pencil first. So where that cut, that 45 degree line, cuts the different points. So here, 1, 2, 3. Yeah, so I'm looking in this way. Okay, so the first point I see is this bottom point. Okay, so that's my first point. 1. Right? The next point is on these 2 points, the 2 sides. So it's here and here. The next one again is on the 2 sides, here and here. And then the top point, top corner, which is here. So again, if I impose that as a cut, very simply draw it in, and they'll be hard lines because I'll be seeing the cut head on. So point to point here, 1, point to point here, point to point here, point to point here. So I just put the green line on the inside here just to indicate that this is the cut. So that's the cut on elevation. It doesn't affect the plan. You see the same shape with regards to the plan. The cut on the side view on the right hand side, which is looking in from the left, looking into the cut, the green line indicates here how the cut imposes itself on the end view. Okay, on the other side, on the other end view, I'm looking in this way from the right hand side. Okay, so I'm not going to see the cut directly, but what I do is I pick up the points, bring them across and draw in the shape of the cut as a broken line. So again, I bring across the points of the cut. So again, instead of having a full hard line, what I do is I draw in a broken line. A broken line indicates what is there but you cannot see. Now, so we have the elevation, plan, end view looking in from the left hand side, end view looking in from the right hand side. Now I'm going to shade in the cut surface. So the green line is the cut surface. So on the plan, this is going to be the cut surface here. So I'm going to shade it in. And this is going to be the cut surface over here. So, the cut surface on plan, cut surface on elevation as a line, and cut surface on this side view looking in on the elevation from the left hand side. So the next thing I can do, just for clarity, I can index the different points. So very simply, if I index it on plan here, so I can list this as 1, point 1, point 2, point 3, point 4, 5, and 6. Now again, if I'm looking at it in this instance here on the line, I have point 1 on the elevation, point 2 and 3 is the same point here, and then point 4 and point 5 is this point here, and point 6 is here. Now, on the plan, I have point 6, I have point, again looking at this here, I have point 4 and point 5, then I have point 2 and point 3, and then I have point 1. Okay, so that's the indexing done with regards to the elevation, the plan, and the end view on the right hand side looking in from the left. Okay, now what I want to do is I can see how the cut has imposed itself on the different views, but what I have here with regards to the elevation, the plan, and the side view, I have the cut imposed, but I do not have the true shape of the cut. Now I can find out the true shape in a number of different ways. So I'm going to show you the different ways you can develop the true shape of the cut surface. First of all, first way of doing it, I know that the cut is at 45 degrees. Okay, so what I'm going to do very simply is draw a 45-degree line on this side here. So anywhere, I'm just going to impose a 45-degree line. Okay, impose a 45-degree line anywhere along here. So that's the 45-degree line. Now I'm going to draw that in red. Now what that line is going to represent, if I put that line in on plan, it represents this line here. It's a center line. Center line. And this here is going to be a center line. Okay? Now what I'm going to do is bring across the points. So I'm going to bring across the points to that 45-degree line, which I've just drawn in. So I'll simply, instead of using that, use the t-square, and I'm just going to bring across the points from the top of the view and use this point as in order to keep it square, right? So bring this point across, next one, next one, so I have each of those points, point 1, 2, 3, 4, 5 and 6 established on this center line here. Now what I'm going to do is draw that a 90-degree line across from where those points hit the 45-degree line. So I'm going to use the pencil here. So top point, number 1, number 2 and 3, number 4 and 5, and number 6. Okay. So point 1 and point 6 will be on the center lines. This is the center line here on the plan. The center line, if I put the center line in on the end view again, okay, I will use red. The center line is this line here. So that's the center line here. So I already have point 1 and point 6. They are on the center line. Point 1 and point 6. So I'll indicate that here, put it in green. Point 1 and point 6 are already established. Now what I'll do is simply get my widths. I can do it on both the plan and the end view. So the next point on the center line here, I put my compass, okay, and then I establish the width, right? These are the true widths on the end view, 2, 3, but it's also the same here on plan, same distance, 2, 3, center line, same. So I'm on the center line here, and I simply mark off what is going to be number 2 and number 3. Okay, it's the same width for center line to 4 and 5. Likewise on plan here, 4 and 5. Again, center line here, put it around, 1, that's 4 and 5. So I'm going to mark those points again with a green marker. So again, I have two indicators here, points 2, point 3, point 4, and point 5. Now if I connect those points up, I have the true shape of the cut surface. So point 1, point 3 here. One to 2, 2 to 4, 4 to 6, 6 to 5, and 3 to 5. Okay, so that indicates now the true shape here, true shape of the cut surface. So in effect what I'm using here is a swivel point. So on the cut surface I have the true length here on the cut, on the elevation, okay, but I don't have on the side view or on the plan the true shape, because when I'm looking in at the end view I'm seeing this 45-degree inclined plane, inclined cut, but I'm looking at it on a vertical, not on the 45 as a true length. So what I'm doing is I'm simply amalgamating two pieces of information. The true length line of the cut on the center line here, so that there is the true length of this line and this line, this is it here, okay, and I'm using then the true widths established from either the end view or the plan, okay, and I'm bringing them off the center line and establishing my different points, okay, on the cut surface. So that's the true shape of the cut surface. That's one way of doing it. Another way of doing it, again, simply what you're looking at is the 45-degree line here, because that's the angle of the cut. So what I'm going to do in this instance here, I'm simply going to bring off from the cut surface on elevation, I'm bringing the points off at 90 degrees to the cut surface. So that's just a simple return of 45 degrees. Okay. Now, in this instance, what I'm doing is I'm putting the center line in a position whereby I can draw this comfortably and accurately. Okay, so I draw again what's going to be my center line. Okay, I'm going to indicate this as, again, in red. So that's at 45 degrees. It's going to run parallel with the cut. Okay, so that's my center line here. Okay, and on the center line, I already have established, because point 1 and point 6 are all on the center line, okay, this here is point 1, this here is point 6. Okay, now, again, what I simply do is I get the compass, establish the width from the center line, either from the plan or from the end view. Okay, and I go each side of the center line. Okay, now I can mark these points in likewise. So I have point 1, then point 1 to point 2, then 3, and then you have 4 and 5. Now I simply connect those points again in order to establish the true shape of the cut surface. So again, I have a true shape established over here of the cut surface. So this is identical to here. Okay. So true shape is established here. Now, there's 0.6 here, and I'm simply going to extend that compass now from 6 to 1. Okay, and I'm going to pull that around onto the horizontal. And then points 2 and 3. Pull that around onto the horizontal. Points 4 and 5. Now, I'm going to indicate those again just with ink. I'm going to use French curves to indicate the use of the compass. So now what I've done is I've brought points 1, 2, 3, 4, 5 using 0.6 as a swivel onto the horizontal here, and I'll indicate then again this as a horizontal. Point 6 there, and then I bring those points down to the plan. Okay, and then I bring the same points out. 0.6 stays where it is, so points 4 and 2 brought out, and points 5 and 3 brought out. Now, if I index those, 0.6 stays the same. Okay, so 0.4 here, 0.2. Now, 1 point to bring the center line out here. Okay, so that's 0.1. You're flipping it over. Then you have points 5 and 0.3. So if I index these now, you have points 1, you have 0.4, 6, sorry, that's 0.2, 0.2, 0.4, 0.6. Then you have 0.1, 0.3, 0.5, and 0.6. Now if I connect those points, again, I will use a green pen for this. So 1, next line, just simply connecting those points up. So what I now have again is a replica of the true shapes that I've developed in the other instances. So I have true shape of the cut surface here. Okay, this is the center line here. Okay, so this is the true shape of cut surface, and this is also the true shape of the cut surface. So now we have the elevation and the plan of a hexagonal prism cut at 45 degrees. You have the imposition of that cut shown on the end view here on the right, looking in from the left hand side. You have the broken line here indicating the cut as the imposition of the cut on the left hand side, looking in from the right. Then you have the plan drawn in, you have the indexing put in, you have the first way of drawing the true shape of the cut surface, because you cannot see the true shape on the elevation or on the end view. So you have to show what the true shape is with the two pieces of information that you have. You've got the true length of the cut here, right, from point 1 to 6. That is a true length line of this line here. Okay, so you're using that information plus the true widths. The widths are true widths. So you've got the true length of 1 to 6, and then you've brought your points across 45-degree line here, and you have the true widths in place. So that gives you the true shape of the cut surface. Then the auxiliary one here is just simply bringing the points off the cut itself. Okay, a line running parallel to the cut at 45 degrees. That represents again the center line. And then you're simply getting your widths from either the side view or other plan, and you simply put your widths in place, index it, and you've got your true shape likewise here. The other way is to use a swivel point. So point 6 is a swivel point, and you simply bring points 1, 2, 3, 4, 5 around onto the horizontal, and then you bring those points down to the plan, bring the points across, and then simply index your points. So point 6 is the swivel point. Then you have point 4, point 5, point 2, point 3, and point 1. That again shows you the true shape of the cut surface. I hope you found that useful.